Hi, my name is Mike Splash. I'm Senior Hydrogeologist at the Dragon Corporation. Dragon is an environmental consulting firm with offices in the United States and Canada. These are the webinars that we have already placed on our YouTube channel, which you can find on our website under the heading of Understanding Groundwater Contamination. We have discussed approaches we use to better understand groundwater contamination problems so we can help our clients get it right the first time. Today, I'm going to briefly discuss several of the projects where we use standard, high-tech, and high-resolution approaches to help our clients. We have saved our clients millions of dollars in remediation, and we have helped adjudicators to understand complex soil and groundwater issues in litigation cases. So today we're going to put it all together. So let's get started on the mini case studies. So this site was a fuel release where a source was missed. So the problems that were in place when we got involved, 1A, there was a fuel release here near a lake, and it was by an overfill. So the actual release was witnessed. There were vapors in a sanitary sewer that ran from the top left to the bottom right, 1B. There were potential discharge into this adjacent lake, and the remediation was taking forever. What we noticed was there were spatial issues in the impacted media. There were the east and west sides of the impacted area were at different elevations. There were no impacts between them, between the east and west side. And the chemistry suggested different ages of releases in the east and west sides. What we did was we put in some data loggers. High resolution groundwater flow maps were the result. We were able to find a groundwater divide, and where normally you would think groundwater flowed from the land to the lake, we found that the sanitary sewer often controlled the groundwater flow. We often also noticed that the phase one of this area missed a tank that was located on the adjacent property. We revised our CSM and the problem was fixed. The regulators agreed with our conceptual site model. And as a result, no further action was required. So a remediation that was going on and on and on really wasn't our client's problem. The second case study is a historical release of TCE at this manufacturing plant that dealt with aluminum tubing. And there was also TCE in the groundwater in the subdivision, and the people in the subdivision used the groundwater for their water supply. There was only a short amount of time for us to figure out what was going on at this site because it was part of a transaction that already had been involved in lots of investigations that were kind of problematic. They resulted in a proposed pump and treat remediation, and also there was threatened litigation because the groundwater flow that the previous consultant had used or determined was from 1A to 1B. So what we noticed was the previous consultant had entirely missed a second aquifer. They thought all the permeable material was one aquifer, where in fact there were actually two aquifers. They reported the groundwater flow from 1A to 1B, and the groundwater velocity was moving unrealistically fast. what we did was we conducted a detailed hydrogeologic investigation of the property up here around 1A. We did this very quickly. We actually determined that the groundwater flow was from 1B to 1A, and that 1A its impact was controlled in the shallow zone by the hydrogeology. We revised the conceptual site model, and we used a model to guide the monitoring frequency, which was appropriate and not just quarterly or semi-annual. It was based on how fast the groundwater was flowing. So the outcome was no pump and treat was needed, saved the client millions of dollars. No further action eventually, because we eventually, when the building was torn down, did a remediation. There was no litigation for our client, and we determined that the real source of TCE came from number 4. This was another similar operation that was upgradient of the residents who had TCE releases. The third case study is one of nitrate in groundwater. It's a permitting issue at a dairy, large commercial dairy. This area is one in which there's legacy nitrate, meaning there's nitrate from past activities, and the concentrations are very high. But our client needed to differentiate what contributions the dairy would give to the groundwater. But if the legacy nitrate coming onto the site was large, which it was, well over the drinking water criteria, the groundwater flowed from northwest to southeast, then what were you going to do? So at 4A was the background monitoring well. And what we expected there was that you would see the legacy nitrate, but you didn't. So we had to figure out why you didn't see the legacy nitrate. So what we did was some high resolution groundwater monitoring. We evaluated the nitrate in different areas, up gradient and on site, by isotopic methods to see what was chemical nitrate, which was the legacy nitrate, and what was potentially nitrate from the dairy operation. We used water isotopes to figure out why 4A was problematic, and what was happening was the groundwater was mounding at 4A because of runoff from non-production areas, ponded, and caused the groundwater to be diluted in nitrates. That's why the background monitoring well had a very low nitrate concentration. So we were able to revise the conceptual site model, and the outcome was that the regulators allowed a higher background nitrate value so that the dairy could operate in a realistic situation. The fourth case study is an industrial release of TCE in a complex geology. Our client was at 1A, and they had a release, and they had done cleanup. Groundwater flowed from northwest to southeast. And what we found was there was a hot spot on the other side of the road with similar chemicals at 1B as to what we saw at 1A. Not exactly the same, but similar. And the groundwater went from 1A to 1B. The conventional monitoring, which included monitoring wells along the road and on either side of the road, indicated that 1A was not the source of 1B. However, the geology was shallow, fractured bedrock aquifer, and the regulators basically said that we could never know and never find all the flow paths. And what was happening was we were missing those unknown flow paths. So there was litigation going on regarding this groundwater plume. So what we needed was a non-Darcy based approach. We had to find ways of proving that 1B and 1A were either the same source or different sources, but didn't involve groundwater moving across the road through fractures. So we did high resolution passive soil gas. The TCE gives off volatiles, and we did a map that showed us the distribution of volatiles, which showed us the sources. We did compound-specific isotope analysis, and we were able to demonstrate that there were actually two different sources. So the passive soil gas had shown bullseyes on both sides of the road, indicated two different sources. CSIA, the compound-specific isotope analysis, showed by the isotopes in the TCE that there were two different sources. The problem was a phase one that was done here at 1B showed that the soil had no impact. So we dug in to that phase one and tried to figure out where the disconnect was. And it turns out when they built the building at 1B, they scraped all the soil away and brought in clean fill. So that explains why there could be groundwater contamination, but not soil contamination. So we strengthened the existing CSM by using non-Darcy based high-tech approaches. And the result was the clarifications helped the adjudicators decide responsibility for TCE on the right side of the road. Case study 5 was a TCE release at an aftermarket auto parts facility. At 1A, they had the TCE release, and the regulators had indicated that our client could not have any TCE leaving the site in the groundwater. So our client had established a pump and treat system, and you can maybe see these little white houses, which were the pump houses. So this was going to go on forever. So we took a look at it. What we noticed was there was a stream flowing through the site, and that the impacted groundwater discharged to the stream. What we did was we created a groundwater flow model with ModFlow, and in that we shut off all the pumping wells, and we demonstrated that even with the pumping wells off, that the groundwater discharged to the stream, and the stream met surface water criteria. So we were able to revise our conceptual site model, turn off the pump and treat, and the outcome was that all the client had to do was monitor surface water leaving the site. There was no remediation required. Finally, this is a fuel release where there were multiple operators. This was a litigation problem. So at 1A, there was a gas station with multiple owners over time. There were releases over time. And the groundwater was flowing from the gas station through a community, and it impacted the groundwater, and there was free product out there as well. So the litigation involved allocation of responsibility of the contamination in the subdivision from the various owners over time. So the opposing conceptual site model, the expert used a proprietary additive in their gas as an indication of the extent of their impact, and basically said, well, we don't see that additive over here, therefore the impact can't be our impact. But what we did was we researched the transport properties of that proprietary chemical and found that that proprietary chemical doesn't travel nearly as quickly as some of the contaminants like benzene and toluene that were in the groundwater plume. We demonstrated that the opposing experts' conceptual site model was wrong, and our conceptual site model indicated large impact by the other owner. So the outcome favored our client. So in this series, we have covered 9 tools to help with groundwater contamination problems. And really the 10th tool is in your hands, and that's peer review. In a peer review, what we suggest is to contact a firm with a higher level of training and experience than you used before. Have that firm review the provided data and information plus additional materials that they would know about. Identify significant data gaps. Identify inconsistencies between data types like the chemistry, hydrogeology, and models. Everything needs to be consistent, pointing to the same conceptual site model and understanding of the process. You can't have chemistry saying one thing and hydrogeology saying another thing. Identify the major errors in interpretation, calculations, and models, and determine whether high resolution or high tech approaches could help better understand groundwater contamination so you can get to a solution quicker. So all of these projects began with a peer review. These are projects where we saved our clients lots of time and effort and money. Just realize that consultants have different capabilities. Most can handle the simple problems and get it right the first time. Not everybody can handle the difficult problems, and it is the client who pays. So thanks for listening, and hopefully you've enjoyed this series of webinars.